Okay, welcome everybody. And we've been working with bar plots in ggplot2, looking at how we can plot more than one categorical variable on a bar plot by using fill color. And we can construct stacked bar plots that way. So we've seen like relative frequency stacked bar plots where we kind of even out the heights so that we're giving these proportions relative to the grand totals of each of the bars on the x-axis. We've also just give frequency stacked bar plots where we're giving counts. There is another position that we can use, which is called the Dodge position, which creates what are called, you might have seen these referred to as clustered bar charts as well. So I'm going to create a similar bar chart using the penguins data frame. I'm going to map species to X, the sex of the penguin to the fill aesthetic. And now I'm going to use the Dodge position for the bar geome. And what this does is rather than stack the sex on top of each other, it puts them next to each other. So for each species, I get 3 bars next to each other, one for each of the sexes. So for the Adelie, I get a red, a blue, greenish, and a gray for female, male, and NA. For chinstrap, I just get 2 bars because there were no missing values for chinstrap. And for Gen 2, I get 3 bars again, side by side. So these are clustered side by side as opposed to stacked on top of each other. But otherwise, we would read them the same way. They're telling us something about the counts for each of these. Um, we could use faceting to get a very similar looking plot. So instead of using the Dodge position in the geome bar, if instead I add a facet layer for species, so here I'm going to set X to be sex and the fill also to be sex. Then I get virtually the same exact looking plot above. There's really not much of a difference data wise. It just kind of looks a little different. We get these nice labels up here. So I don't know, maybe this looks a little nicer from a presentation point of view, but it doesn't look all that different from like a data, how the data is presented point of view. So I just want to kind of let you know that there are different methods for presenting the data in a very similar sort of way. Um, if we so this is useful if we want to compare like the number of penguins with each sex within each species. So if I'm like, okay, Adelie, did we have more females or males for that species? We could see here it's about the same. Chinstrap, it's about the same. Gen 2, I can see that I had more males than we had females. That's a fine looking plot to do that. If I wanted to compare the number of penguins from each species that are male or female, it's a little bit difficult to do. So, for example, if I wanted to say, like, which species had the most male penguins, I mean, it's not, it might be more convenient to put all of the male bars right next to each other rather than spread them out. So, we can do that. As well. So here I've created a plot by putting sex on the X aesthetic. So that means all of the females are going to be grouped together on the X axis. All of the males are grouped together. The NAs are grouped together. And we put species on the fill and then we dodge them. And so this way we can kind of compare counts for male and female. And again, I'll always just add this caution that, you want to be a little bit careful when you're comparing counts, particularly when you're sample sizes have very different um, counts. So the chin strap sample was much smaller than the Adeli sample and the Gen 2 sample. So just because we have smaller green bars doesn't mean proportion wise there are less female, the proportion of female chin strap is less. So you just want to be careful when you're comparing counts versus proportions when your sample sizes are very, very different in terms of counts. Okay, so question 8 is saying let's construct a very similar graph as the one above. So why not copy all of this code then? But we're going to use faceting instead of dodging. So let's get rid of the dodge. So for each panel, since each of these panels was female, male, and NA, we wanted to map each sex to a different panel. And then within each panel, we're plotting different bars for each species. And each of those bars, we want to make a different color. So that's why we're mapping species to X and the fill aesthetics in the geom bar. So this is telling us what each bar plot is going to look like in each panel. And then this is telling us what each separate panel, how we're going to dictate how each panel is going to be created based on sex. Okay. So, yeah, I just want to say that, you know, these are examples where we've got categorical variables for species and sex that each have like 3 different classes. In the next example, in the next video, we'll take a look at a different data set where we have categorical variables that have more classes to see how this choice of position maybe becomes more important when we have more complications in our data. But we'll stop this video here before we change gears and take a look at a different data set. Thanks.